Hello coders, I'm Celestrio G, Jacoba, and we'll be talking about logic formulation. Now, on this topic, we should be available to learn to identify and explain each step involved in programming cycle, and explain the use of algorithm, determine the procedure of pseudocode. What is computer program? A computer program, also a software program or just a program, is a sequence of instructions written to perform a specific task for a computer, like this board. This Java programming and this C++ programming is about developing or coding a code or a software to present or to do a product out of it, or train your coding skill out of it, so that you can create a app, website, or games out of those things. In Microsoft, this is an operating system. What I know, one of the only I know is Microsoft and Linux. That's the only thing I know. And Linux is a free operator. You can download it whenever you like. You can switch to operator, like switching to Microsoft and switching to Linux at the same time on your computer, or in your computer, or on your laptop, or in your laptop. And if we talk about software program, we can talk about like this the thing that you will need to download in your computer, or that you want to download in your computer, like a gaming program or gaming software, like Steam, and Riot. So you can play Dota 2 on Steam, and you got Dota 2 in Steam, and you can play Valorant and League of Legends on Riot. So you will be you need download those things, this thing, and after you download this to Steam and Riot, you need to download the in Steam the Dota 2, and if you want to like to play League of Legends and Riot, you need to download the Riot, and you need to download the League of Legends and the Valorant separately after you download those things. There are a lot of things to need to download to use your pleasure app. Okay? Same goes in your cell phone. And cell phone operators, we have Android, iOS, and a lot of things in there. And after that, we talk about program cycle. In program cycle, you need to identify the problem first before you create a program. After you identify that problem, you analyze it. After you analyze that problem, we're now creating an algorithm to develop. Okay, to develop an algorithm. After you develop, create an algorithm for that problem, you now code it. After you code it, you'll be debugging it after. After that, after you code debugging it, you see a problem, you code it again, and that a lot of process going back and forth and back and forth and back and forth till the system is done, or the project is done, or the product you're doing is done, so you can sell it, or sell it to the masses, or test it to some people, so you can know if it's working right or wrong. After that, we talk about algorithm, a step-by-step problem-solving procedure, especially an established recursive compilation procedure for solving a problem in finite steps. We talk about finite step. We talk about a limited step to solve a problem, like solving a um plus equation kind of problem, like solving a math problem. Talk about that. After that, you have the characteristic of an algorithm. You need to specify the each step of the instruction exactly, and there must be a finite number of steps. So finite, you just need a 1 to 10 step, or 1 to 5 step, or 1 to 3 steps to solve this kind of problem. And there must be an output at the end of that steps. Now, so what I mean, the output should be the user be seeing the outcome of what they did. so they know this. They know that they. I mean, is so they know that the system or the system of the software or the product is ended because there's an ended output or shown to them that, oh, you done our project or done in this process, like that were like so, so far. And after that we talk about pseudocode. And pseudocode is a generic way of describing an algorithm without using any specific programming language syntax, and it cannot be execute it cannot be execute on a real computer, but it models and resembles a real programming code, and it's written actually at the same level of detail. Same level of detail is a pseudocode is not really a programming language. It's a English of everyday. Like say if I use the equal sign, plus sign, every sign you like. Will be no comma or parentheses or curly braces and other sign that we'll be using like semicolon, colon to indicate the end or closing and the separation of different kind of things. Okay, you need not need to pack those thing in a pseudocode. We'll be using a word to say if that is a if else or a for loop or is a kind of procedure that we'll be using so that a programmer can know what they will be doing, so they know what will be the procedure or step by step of it, like this. If the student grade is greater than or equal to 60, print pass, else print fail. Easy to understand what we'll be using here. The programmer can see it and say, oh, this paper says if the grade student using if else, so I'll be coding if the 60 equal, okay, using if or parenthesis and then 60 60 and less 60 and no, grade is greater and equal sign, and after that else and procedure, so easily understand by the coder. And this is the steps in problem solving. First, produce a general algorithm. One can use pseudocode and refine the algorithm successively to get step-by-step detailed algorithm that is very close to a programming language, a computer language. A pseudocode is an artificial and informal language that helps programmers develop algorithms. Pseudocode is very similar to everyday English. That's what I'm talking about. Excuse me. I'm still full. I eat it. I ate a lot before I started this recording. So excuse me. So that is pseudocode. So that is pseudocode. Say see, pseudocode can be used verbally and can be written on paper or can be sent via email or anywhere, as long the pseudocode is readable for a programmer, and the programmer know what is the language will be using and what the step by step is written up from down, as long they can see it's written up and down and has a word or keyword from a language they will be using. They know what will be the, the program. They will code it and will show you the output, will sending that, and if there's revising, you can revise that after they represent the code. And that's all for the week 2. Now let's go on week 3 of this logic formulation continues. So we are on logic formulation again. This is a the continuous of logic formulation. So in this one, we'll be talking about, as you can see, I already have a hint from here about a recognize the use of each flowchart symbol will be used to illustrate and design a flowchart on this topic. In flowchart, there should be a chart that contains simple representing a computer operator describing how the program performs. And symbols such as squares, diamonds, oval represent various different operators. Represent different operators. I cannot pronounce this well. Barriers and barriers operator. This is and these symbols are connected by lines and arrows to indicate the flow of the data or control from one point to another. So this is the symbol of each flowchart. As you can see, we have terminal block, process, input, output, and this is condition. This and initialization on page connector, close line of page connectors, and documents. We'll be explaining each one of them. I think the documents is not needed, but it's a lot of missing here in the lesson be given to us. I mean, the one is let's say this cylinder one, data for our data, but it should be another kind of lesson. We're talking about, I don't know, but first we talk about indicate the flow lines. By straight lines with arrows show the direction of data flow. Arrow head is sometimes not shown when direction of flow is clear. It's used to connect blocks by exiting from one to and entering to one another. So as you can see, if there's no flow lines, we cannot determine what is the flow. Is it going down or going up? We don't know it. Okay, we don't know it what is happening from there. But as you can see in this side, we know what is going. We know what is the flow. It's going down the procedure. The procedure go first here, afterward there, we go here, because the process from here is done. Okay, done. And terminal block, ovals are rounded, rectangles are used to indicate the start and the end of the module or program. An oval is labeled with the name of module at the start. Okay? And the end is indicated by the word end or stop for the control. So, control, as you can see here, we have that words. After that, the start has no flow lines entering it. As you can see, there's no flow lines entering from it because this is when you click your software or your program that you'll be wanting to use, like any kind of games you'll be using, like Roblox, League of Legends, Dota 2, Minecraft, Valorant, Dota 1, Warcraft, anything you like. Okay, this is the first thing you do. Click it, and this means starting. That is the word start come from. And we have the exit has one flow line entering it but not exiting it. That can you see? Because this is when the time you're closing your program. As you can see, the program is ended, like clicking X on a tab of Chrome, okay, or by Google. That is when you see that is closed, because there's no show something like anything, or by closing your computer, and that is the end of the program. Literally end of the program. Of every program that's running on your laptop, of your laptop, computer, or cell phone, or any gadget you have, by clicking or pressing that power off button. We're ending the every program running from there. Like terminating. After that, we have the initialization block used for declaring initialization variables needed to solve certain process. Declaration binding of identifier to the information that relates to it, stating a variable name to be used. And installation is to set a string variable, int variable, like like starting variable, like everything you really need to be used, so that goes down. Anyways, this variable can be anything variable. It can be object variable, anything. Just pass here in the initialization back there to prepare a computer or printer for use to boot or to format a storage medium such as this. After we have process. Okay, the difference of these two same. This area is the same, right? But we have different shape. As you can see, the initialization block has a six corner. Okay, six corner has a six corner. Yes, has a six corner. It's a piatos. The piatos or like a hexagon. If I'm correct, it's a hexagon shape. Have a six corners in it. In a rectangle, we have a four corner. I forgot the shape. I forgot about it. Indicate a process block for adjusting calculation of the enclosing files and so forth. So what is the difference from processing in initialization? Well, in a process blocks, as, as we said, is calculation, and in a initialization block is setting or stating the variable name, that saying that x is equal to 10 and y is equal to 10. There's no calculation happening. But why is a is in here but are here but they have no calculation happening? Well, a is needed there because being using here uses here. See, this is what's happening. And as you can see in this the flow lines we see here is because this is not the end or like this thing. They have a one entering exiting using flow lines. So it can be that was here later on. I'll be explaining. Later on we'll be seeing the whole flowchart. Let's explain the block first, each block. After that we have the input and output. Alright, input and output. Yeah. This input output has four corner but is a parallelogram, indicates the input and output operators. So as you can see in input and output operators, to identify that you should be able to see the word get or input wrong spelling. Input. Yeah, there you go. Input, that's how you spell it. Yeah, there you go. Input. You should the word input or insert. Those words should be insert. Go insert and just to determine that this is an input block. To determine that this is an input block. So that you can, if the prof or the teacher or the client or other people will be seeing the flowchart available to guess that this is this is the input. This is one you need to input. This one is needing the input from a user. I guess that this block I thought this is a display. So if there's no word that contains import or this import insert display, it will be hard. It will be hard to understand for the proper user. They will be confused. And display you can use the show word or the print word. You can use those words, these three words. You can use the input to show that this is a output block, so that they will be not confused once they see the parallelogram, because it has two uses. Okay. After that we have a condition block. Alright, condition block, it has a diamond. It's a four corners. If you turn your head around, it will be parallelogram. If you turn hard enough, it will be a square. A process block. It has a one, as you can see, let me change my pen to a laser point. As you can see, it has a one entering it, but it has two exiting it, because they are should be as is as should be, there's only needed to be one entering it and two exiting it. Right? It has one enter and exactly two exit from the block, because it only has a true or false happening in there. Excuse me. Excuse me. Excuse me, guys. Excuse me. I hate that. I hate that. I'm very sorry. After that, there will be a action afterwards. You can see action afterwards there. So let's say if the input is equal to 1, and then will be printed true. If input is not equal to 1, then it's printed false. It will be like that. It will be like this will be the outcome of true or false. Afterward, we have a one page or all page connectors. As you can see, the circle uses connection point between two sections of flowchart that are not adjacent or close or closely located to each other. If they are in one page, if the the on page, the symbol of off page is a circle. If they are on the one page, but kind of not, there's no space on below, but they have a space on the side, you use the on page, this one, two, but on here, like this what's happening. If there's no space below here, you use this, so you can use this other side of the paper, or the space of the presentation, so that you can not a lot of you will be not wasting a let's say a paper, and at the same time you can explain it more successfully and more readable to the view of the use of the from the prop and the other people will be seeing that flowchart. It will be more readable. And keep in mind, it should be use it as little as possible. If you overuse it, a lot of like on page and off page connectors, it will be decrease the readability and produce a cluttered effect. Like what is this? How if the I mean, you know this, if you have no knowledge about flowchart and you see a lot of circle and a lot of these kind of symbols, I will be asking yourself and you will get confused. What is happening here? Like this, I'm seeing this circle that has symbol A going here and here and here and here, but what is doing? What is this? Too many A's I've been seeing. So as much as possible, reduce the uses of the off page on page. If you can use the flow lines instead of the off page, use the flow lines as much possible, so that it's much better to be readable to a person that has no knowledge on it, and must be readable to the prof or the teacher be reading the flowchart of your flowchart. So we have an example one here, a star. After the star, we have initialize the age equal to. After that, we have the age. It should be name. You know that when you're programming every programming language, you cannot have two same name, or else will be having problem in program, will be error. But that's okay. This is just an example. You're not coding it. Age is equal age and plus. If 18 plus age, this will be 23. It will display age. Display age will be talking about print out, display, or paragraph, or anything kind of that. And after that, the system is stuck. So, and after that, we have decision structure. A condition I statement that result to a boolean value. The value of boolean may either be true or false. It can be 0 or 1 value. Conditions are categorized in two: logical operation and relational operation. In three basic logic operations, there can be a let's draw this. I know others will not know this, and others will not know this. But in logical operators, if we talk about AND, you can see this on programming language. I don't know if it will be same syntax on other language, but that is will be the syntax for it in Java. And if or this will be the syntax in the Java programming. If not, this will be the syntax of not. Okay, that is the syntax of not. After that, I get focused and tired of not. So that is the logical operators of each. Later on, I will training the uses of each one. Right. After that, we go on logical operators, and the or has no okay. Yes. And or are logical operators. They commonly use logical operators. A logical operator that negates the result of the Boolean value. Later on, you'll be seeing what mean that negates. Okay, this is what I mean in negates. As you see, if the value of condition is false, it will be reverse the logic of it. So if the condition, let's say that input A, the input of a user is not equal to 1, that will be true on the not A. Okay, not A. It will be true in not A. But if the condition is 1 is equal to 1, is A is equal to 1, it will be true, but on the not A condition, it will be false. Okay, this will reverse the outcome. Excuse me again. Alright, it will reverse the outcome of the Boolean expression. And this is the example of AND or truth table. You can see if the two condition is false, this is false, right? And this is false. But why on this page this one condition is only F, but this F and this is false, but this is true. But there is a way to explain this pen. Later on we'll be using pen. As you see, there's a sequence. If there's only one that is false on here, there will be from here will be false. The condition of A and B to be working, in the both condition of A and B to be true, or else will be false. Okay, you can see here this is true, and same goes as here in A or B. If both this is false, the condition will be false. Condition will be false, nothing will be changed. If only one of the condition is true, if one of the condition A and condition B is true, only one of them, okay, only one of them, even is 100 to 1 to 100 condition, same goes to, and if one of them is false, but in or if one of the 100 condition, only one to 100 condition is true, it will show an outcome of true. Okay, it will show an outcome of true. That will be showing. And this one of this is to show this everything from here is false. Okay, from here is false, and this one is false, because as you can see everything is false, and here from here will be true, and same goes with true, because everything is true, while this is true and this is true. It's simple as like that. Alright, just remember that if you see one F on here, everything's false. Just every one of them false. you see everything is false. Okay, false. If you see like let's try bracket. Let me give me a higher, much higher. Let's say I cannot. I said family. I cannot make the marker the pen larger, but they say that if I become the color on this side, this let's say that I block the B condition B and C, not C the condition of B and C. You know what? One of yeah. I will not give you longer explaining. But yes, that is what happened in there. Let's go in the next slide. I'm getting tired. I'm very sorry. I'm getting tired. We have a long 19 up to 36 slide. It's a long slide. And now we are talking about relational operators compared to values. To create a boolean, we have less than, greater than, less than or equal, or greater than or equal. And this one is just like simply same condition. It just different it just have a different sign, but it's just a same outcome. And if you talk about this, it'll be easy. I'll show it here. So I know if x is less than y, of course, it's true. X is greater than y. Is x is greater than y? No, it's false. True. False. It's easy as that. And of course, false. And of course, true. Yeah, x is not equal to x. That is true. I kinda hard to get it, but that is how it's happening. Since it goes there and there, if no, if the 12 now, no, this is kinda hard in this part. If you talk about there, as you see, if you talk about there, that side, if 12 is less than y, of course it's false, as you can see. It has no equal sign as long here false, but when go here will be true and true. Out here will be, of course, will be false because x and y is equal, but we're talking about x is not equal and y. Okay, so false. That is what's happening in here. Alright. Kinda easy to explain as long you remember these symbols, as long you guess these symbols. Alright. As long you guess those symbols, as long you remember those symbols and you know their meaning, it will be easy. It will be easy to understand. It will be easy to answer this exercise. The more on condition block. There's a in condition block. As it should be noted that what we play inside the diamond box or are condition that either result true or false. No, you don't place condition that are in a form. You must be able to represent it in a mathematical form like this. Let's use some laser, and as you can see, like this, like that. Let's take it. Single alternation. Let me do this. Let me do this. Addition box may not, unless I have to do something for both the true path sample and the pass false sample. Print x. What is it? X now. See. So if the condition that let's say x. Alright, so I don't know what will be the display, but display this. Just display the word this. I mean hard to throw this. So that is will be looking like, and this will be starting. The S will be the cycle. That will be the look of the flowchart if you ask me. No. It should be have no. There you go. Should be have should have first a initialization blocks. Yeah, initialization. After that we have a blocking terminal block like that. That is how easy to represent if you're talking about that. That is how a full-blown flowchart look like. It's already shown. It'll be here will be the X and Y initialization. After that, displaying perform two different, and this is the two have a two different outcomes. Will be shown. It has two different classes, but it has only one outcome that display that output that we're getting. Otherwise, split Y. Split X, otherwise means Y. That is happening here. After that, we have a multiple decision box. And this one, we have the example in here. Create a flowchart that asks the user from 1 to 3. So if the user entered 1, it is stated hello. If the user entered 2, it was stated hi. Excuse me again, still poor. If the user entered 3, it will stated bye, then otherwise print invalid. This is what it will look like. You can see initialization, input, and decision, and output. After each output will be the end terminal. Okay, it's a full blown. It has a position, and we can see the flow line. So I see the flow line. You can easily see the flow line. Easily see it. Easily readable. Not hard to be read, because we already have acknowledged about flowchart. That's why it's not hard to read it. Now use decision block with ranges like this. Create a flowchart that will print the name of the supervisor under the certain department number. Under a certain department number. Okay, like this. If the department number is less than or equal to 3, will be Mr. X the printing, same as in the department equal to less than to 7. It is cool. No, this is right. This is right in coding. Let me see. Oh yes, this is okay. You'll be using a if and else. We're using here, and here you will be using if and else. That will be happening here. That will be happening there. So if else. Alright, so if the condition is true, then go here. If the condition is true, go here. If else, if condition true, else goes here and click this one, and the program and the system, the product. After that, we have looping instruction. This looping instruction, you can use it from for loop, while loop, and do while. Okay. Ayan, you can see I'm getting tired because it's a long video. Repetition structure is also referred to as loop or iteration. This type of structure is, so if you ask me what will be the full blown of this, of course you have, don't forget the initialization. What's happened to me? Not oh, this is not six corner. What happened there? There you go. Yeah, there you go. A six corner initialization block. So that this is the start the initialization block for load. Yeah. Initialize I. You can initialize I. This is the for loop. The for loop, you can say x is less than 10. 10 is condition. This will be I x I. So I will be here display and will continue and continuously do that. After that, we'll end the system if the I is 10 is 10. So we'll be reading this I will be reading the I 10 multiple time, like I equals to 0, I is less than 10 is true, I is less than 10 is true, blah 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 blah, until it gets to the 10 is 10 less than 10, no is a no, and goes, then we end the system. If so, the I is no longer than less than that 10. That will be happening there. So the action performed by repetition structure must be eventually cause the loop to terminate, otherwise an infinite loop is created. If now if the I now if you not like say if pat let's say if I is less than negative 10, the loop will be never be ending and continuously do this part. Oh man, Erickson. We continuously do this part. Here. They will be continuously do that part. Will be no ending of it. The only way to end that program, just click exit on the program. Please go the see this, click that to end the program. So find a way to end it. yeah, that's how you only the way to terminate that program, because it became infinite loop like this one. You can see how it display the x is a loop, so it goes on. You have this look at the shape again. We have the selection blocks. After that, we have the starting terminal block, and we have the ending terminal block. That's how it works. Display the x, display 1, 2, 3, 4, 5, 6, 7, 8, 9. After the 9, then 9 is 10. Now is 10 is less than y. No, this goes down and will end the program. Yes, it's only displayed the 9 number because it's not equal, so it will not display the 10 number. That's how it's happened. By adding an action within the repetition that changes the value of x, this type of structure is known as pretest repetition structure. The condition is tested before an action are performed. In a pretest repetition structure, if a condition does not exist, the loop will never begin and the action inside the loop will not be executed. So what does this mean? Let's say that if the 10 is greater than, I don't know, let's say that 10 is greater than 10, greater than, let's say, 5, the loop will never start. I know I stated that if 10 is greater than 5, it will be infinite loop. I am wrong. If this I is constantly a 1 value, that will be, an infinite loop. That's what is happening. Okay. If the value of this x is constantly a 1, this will be never be a ending of that loop. It will be infinite loop. Okay. I'm correcting myself. I've been wrong on that statement. That I will correcting myself in this part. Okay. I realized my wrong in there. But that is how it's happening in this condition. Okay. So in this one, using to terminate this, you need to use this kind of words or a command. In if else, this if else, you can use word break to end the program, or you can use this command dot system dot out to exit the program. So that is how done. System out or break, but it's much recommended to use this command instead of this one, because you're terminating the whole program itself. But this one, you're terminating only the loop itself. You're terminating the whole program itself. So this one is great approach that us. This is another exercise. Actually, it's a long one. It's a ginger is if the user enter M, it will display male. If the ginger is entered F, it will display female. Otherwise, it's the invalid gender. And let the user enter the gender 5 times. You can use here a for loop, while loop, do what as long the condition is met 5 times. So repeated 5 times, and that's all. This is the flowchart. Look at it. This is the end of it, the flowchart. You can see the stop or the terminal block can be anywhere as long as it makes sense. Okay, as long as it makes sense, it can be anywhere. You can see the flow line is here, and much readable, much readable and doable to the user eye. That's it. I see. After that, and these references that we get, kind of old references. Yeah. We should update this reference. And that's all. Thank you. Now we ended our lesson. Thank you to listening, and at the same time, please sub to my channel if you like what's happening, or I can change this, because I can change the topic or the way I talk, but I need to speak English. I need to practice English, because a lot of subjects require this. So sub to my channel, like the video, and comment whatever I miss a topic, or miss a opportunity to explain something, or I became like I skip a topic, or I skip a explanation. I need to explain something. I skip a big information out of there. Comment there, and I'll try comment or explain it to you. Or if you want a way to do a flowchart, I can send the link from the comment section. Just say, oh, where's the link for create a flowchart? You can use you can use words and a lot of things, but you can go in Chrome and search Lucid chart to create a flowchart. And pseudocode, you can search in Google and search examples. There's a lot of examples about pseudocode. Okay, that's our whole lesson about. Okay, again, reminder: subscribe in my YouTube channel and like the video. At the same time, click that ring bell to notify when I post a new video. I like to post again if I have a time to edit and I have time to record the video. And at the same time, comment a topic about programming that I can make a topic, but keep it on Java programming or JavaScript or PHP. That's the only language I know right now. Okay, I'm very sorry about that. I'm beginner too in this kind of profession. I'm beginner in coding, so let's help each other from this path. And that's all. Thank you, coders.